Hi, I'm your host Matt and work within the vSphere client group by day, and now a first-time vlogger to share my tips and tricks to help you level up your coding skills. I hope our experience behind the scenes can build a voice that represents the team's passion and engagement with folks like yourself, wanting to learn more about the craft and dynamics of working on a big team, solving complex UI problems. But first, a little history. In this edition, the topic is Art of the Refactor. You'll learn how I take a real-world UI problem we faced recently on our internationalization adoption. The vSphere client app is actually quite big, with the UI-only portion breaking the scales at well over 1 million lines of JavaScript, TypeScript, and HTML templates, all wired together as components. There is a Java Tier 2 for messaging, security, and overall orchestration of APIs. The app has matured and grown up over the years, spanning back from the days of .NET, then transitioning through ActionScript, and now starting from vSphere Client 6.5, completely rewritten to evolve into powering future workloads in the cloud, Kubernetes, all based on the same web standards found in everyday browsers. It's been quite a transformation journey, taking over 400 man-years of refactoring effort, according to some in operational management. I can promise today's journey will be a light lunch workout. So let's first size up the scope of what we're really getting into with today's adventure. So step 1, let's review the current state of problematic code. That is, let's get a grip on what the damage looks like, maybe propose some quick fixes versus a long-term investment. You may have been through this experience. I certainly have. You take your car in for an oil change and those mechanics try to bait you with the whole story that, oh, the brake pads are worn, or you have an oil drip that requires a whole new pump to be installed. Stop sugarcoating the real problem. So before we go for all the gold trim, let's take a step back and assess. Scoping problem domain. We'll first try to get some accurate numbers to engineering managers to show them that the problem looks easy on the surface, but in the situation of the vSphere app with so many occurrences, the effort actually is more overwhelming. I want to remove all traces of this directive. It's called VSC translate, which is in many HTML templates, and replace that with a translate pipe. What is a directive and what is a pipe? Why did we favor the pipe syntax? The directive, it required a tight coupling with the DOM, and it was pretty much impossible to use without having a DOM tag like a span or a div surrounding it, so you couldn't do free floating text. The syntax was odd, it wasn't very conventional. It got even harder to use when you wanted to pass dynamic variables in. Now we're going to standardize and use just a simple Angular pipe. Draft some intended changes and propose what the refactored version should eventually look like. There is perhaps that hard part of implementing the actual transformation, but at least show the logical A goes to B. In this case, A is going to be a few different formats. We'll say A sub 1, A sub 2, A sub 3. They're just variations. And we need to come and fit that back into a generalized expression B. Step 3, take a swing overall at the breadth of changes. Try to visually present the most significant numbers just to see how widespread the exposure is for old patterns. Step 4, once committed to the actual task, continually gauge progress and keep asking honest questions such as, would the long-term benefits outweigh the cost? We're not looking for a plan broken down to the smallest level of detail, but more of an open conversation to keep everyone in tune. The topic of point 4 is brought up often on the large team. We have to prioritize meaningful features versus the maintenance or cost of doing business. Until we notice the need, we take the passive approach of, don't fix it if it ain't broken. In this case, The confusion has been spreading for quite some number of years, and we'll need to disinfect and neutralize that code to prevent further spread. So for step one, let me review the current state of problematic code. That means we're going to go into the IDE here and actually going to look for instances of that old directive that we want to eliminate. So it's called VSC translate. As you can see, well over 1,000 matches in the code base. We're going to have to look at the problem, find out how are these usages consumed. So we can see the I18N key. So in this file we have two different use cases for the VSC translate directive. It's being used as a static string over here, and down here we have it used as an array, likely because there's a parameter which is the length of all profiles. So we'll have to consider that and possibly some other edge cases when doing the refactoring. Just to throw a little bit extra confusion, you can see a developer has chosen to write his own expression, the I18N service get string. Our job is just to reduce the number of ways to doing translations into a very simple expression. For point two, I wanted to draft some changes of the before and after just to get a sense for what needs to happen. So now I want to show what the intended changes are. So here's one example, here's another example. We want to get rid of that directive once and for all. I've taken out the VSC translate directive and written it as an expression that can be piped to the translate function. And there's two use cases. One is static string, and the other is static string plus additional arguments that would be resolved at runtime. Point three, really want to take a swing at getting some accurate numbers to our colleagues and management, just so that we're on the same page. After all, it's going to be a pretty long-term refactoring otherwise, so best to get those numbers. I have an idea. Let's let the computer tell us what those numbers look like, and we'll have a little bit of fun trying to present that visually. So next I want to generate some tabular data in CSV format so that I can supply that to a web application that we'll be jumping into shortly. Making a script that will ultimately scan all the folders under our web application and look for instances of that VSC translate directive. Let's jump back into the bash and, well, bash out some good old comma separated values. So I'm just going to make some variable placeholders here. This is the name of our web application project. The tag that we're hunting for is called VSC translate. And it's just limited to HTML files, so we can safely presume HTML here. And what I want to do is use the power of regular expression searching on the command line. There's a variant of grep called egrep that has some regex powers that I wanted to try out. So first I'm just going to block it by using the \b and try to do a pattern match on that deprecated code. Include, we'll limit it to just those HTML files. Starting from our folder name, traverse the whole project. What I want to do is just sort those results, knowing that the format of the egrep is going to have a file name and a count. Actually, I'm more interested in that count. I'm going to take that second field and send that over to a calculator where I can run some tallies on it. Let's see if that works. Oh good, about 1500. Next thing I want to do is take those numbers, convert it into CSV, because this is where the fun's going to start. We're going to make a web application that visually breaks down those numbers by the features into a more interesting diagram. Let's get to work on using shell script. I went ahead and already typed in a bash script, very similar to the first one, except that it's going to scan through some folders and perform that same regular expression and search. The only real difference is instead of getting a sum, it's going to take each line, display the path and the count for file by file. Let's go ahead and run that. And I have a CSV that is very simple. It's got the path to the file and the count. Now I can go and build a real web application that will read that CSV and show it in a browser. We'll throw that into a data folder. So make sure I have that data folder already existing. For the HTML, I have some pre-rolled markup I've been working on the side. First is a D3 library, really great visualization tool by Mike Bostock. He is the father of data viz when it comes to JavaScript. There's a whole community behind him. I've been using this library for quite some time and highly recommend you check it out. You can see how I have some configuration to pull in that CSV file that we just made. And it's in this render function that is really the heart of using that D3 data visualization. On this line is where we start to get into using that tree map component. A tree map is a visualization that can display a large amount of hierarchical data using nested rectangles of varying sizes and colors. The total area of a tree map normally reflects the sum of its parts, which consist of inner rectangles or nodes. The size of each box drawn is based upon a number assigned to that node, so there is some degree of relative sizing. And this render function is really the heart of the whole application. It is right here where the tree map from D3 is being used. There's some helper functions that I had to write to deal with the syntax and formatting of the data structure. I also want to extract out a feature name, which can only be found by parsing a few sections down into the file path. In the CSV function, I'll pass in the data source. Will just look like this comma-separated file, and it will pull through its rendering routine, which starts off by creating a SVG. We're going to use anchor tags for making those boxes be clickable. D3 has some primitives such as stratify, parent ID, sum, sort. What it's trying to do is take a flat data structure from the CSV file and project that into a model that has some hierarchy and meaning. And that happens with these processes right here. When that is invoked into the tree map function, we can start calling the render. The rendering starts about here, and that will take place by using the SVG tag to then select all of the anchor tags and loop over all of the data. These routines are fairly straightforward. We're going to create a anchor tag, then we'll come in here and draw a rectangle box for where that particular node will be shown and its relative sizing. The width and the height, it can all be derived from the data model. The next part is a clip path, and what that does is it prevents the text from overflowing outside of the box. SVG has some text helpers such as text and text span or tspan. By using the attributes for X and Y, it's pretty easy to place the label anywhere you want. It is very mechanical, so you'll have to understand your layout. So the rendering part of this routine starts with this SVG select all. And what it's going to do, it's going to map and loop over all of the data sets, creating these anchor tags. And the reason why we want to use anchor tags is to make those text nodes be clickable. Once you're inside that, we're going to get into the SVG. So this is where we're actually building rectangles, which will house the actual data element and size it based upon its value that's already been weighted. You'll notice that the width and the height, these are just simple math routines because the data model already expresses those. The clip path, it just prevents text from flowing outside of its boundaries into the neighboring cell. Text is done with the text, and tspan is also for having more granular control over the text. In this case, I want to have a title, which will be the file name, and the line underneath it will have a count. I thought it would be great to try to center that, so I've done some very simple math. And again, it's not CSS where you get a lot of these things for free, but if you understand the math, it should be pretty trivial just by taking the width and dividing that by 2, knowing that the x and the y coordinates are relative to its parent. So it's not something I have to calculate in reference to the entire viewport. I did want to put in a tooltip because I know a lot of these boxes are going to be very tiny and hard to read. So putting in a title will act as that tooltip for now. And I thought I'd just put in, maybe about 4 different items. So we'll put in the path, we'll put in the count, we'll put in the path leading up to the file name, and then a final label. Okay, let's go into the browser and take a look at how that might look. Let's do a little CSS. Let's do a little Bob Ross style and paint some pretty pictures. You know, there's no such thing as mistakes, just happy little accidents waiting to happen. I love CSS. I think it would be good if we just put in some background color to start with. Let's see how that goes. I could play around with the CSS a little bit further and make some changes. We actually have a tree map rendering with all of our numbers, 320. If I did the math right, yeah, total occurrences 1,554. Yeah, this creates a very detailed look at the amount of work that needs to be done, broken down by the domains out there. What we have is a conversation piece. Let's go back and tell the managers we got some work to do. In an upcoming episode, we'll be reconstructing more complex DOM trees in order to automate weeks of work by writing Node.js and some TypeScript hacks. In the meantime, I hope you'll have a chance to visit my GitHub repository in the link below to try out some of the data visualization exercises that were used to nail down scope with our engineering managers. That's a wrap for the first chapter in Art of the Refactor. Don't forget to subscribe and check out the other visionary talent on our VMware Code YouTube channel.